This is Kenny Robinson, and we will be discussing coding.
Yes.
Right. So, let's see. So what do we say? Help me.
All right. So we got 2 up there.
Hey y'all. I can't see who it is, but
Okay. All right. So if you all have any questions, can you comment with those at any point? Basically, the discussion point is to talk about coding and possibly how you can get involved, things that you might want to learn along the way. If you're a beginner, there'll probably be more questions for the beginners than the advanced folks. So, we'll start from there. All right, you got it.
okay, so Kenny and I do our coding thing a little differently. Jay, I know you're a principal in Troy, so I'm pretty sure your kids may or may not, your students may or may not be learning computer programming at your school. But for the younger kids, I use visual block coding, which is simply where they drag and drop and fit the pieces together, kind of like a puzzle to get their object or variable or character to do whatever they need it to do. But Kenny here does.
I do a little bit of everything. So I build web apps, I build desktop apps, I run, I do a lot. So it's the full like Java, C#, PHP. When it comes to databases, MySQL, SQL Server, Oracle. So basically, you name it, I've probably done it or done something that is close to it.
Okay, so I would like for you to explain to our audience, what the different coding languages are.
Okay.
And how they can be used to build different.
Okay. So each. So I would say the main 3 are Python, Java, and C#. And so from there, you can pretty much build anything. Python is usually used in like the smaller applications. So, for instance, the like Raspberry Pis or the Arduinos. A lot of people build whatever they're building with Python in those. Java and C# are bigger with the enterprise level, so like commercial applications. Facebook, when it started, was built off of PHP, which is PHP is strictly web, but Java and C# have desktop as well as web applications for those.
Okay, and then I want to go back and tell the viewers that the Raspberry Pi and the Arduino, those are components. Correct.
Yeah, so Raspberry Pi is a full computer with about the size of a credit card, and it usually has USB on it, has HDMI on it, and it has what is referred to as GPIO pins. So basically, those GPIO pins allow you to switch on and off various components that are connected to them. It allows you to connect sensors. So there are examples where people take their Raspberry Pis or their Arduinos and build like electronics, automation type devices, and so forth.
Can I tell them about your
the traffic light?
Yes.
Yes.
Okay, so Kenny has this traffic light, y'all. Hey Terrell. Hey Mox. He has this traffic light that he has programmed to.
So I use it as a teaching tool. A lot of the school systems here in Montgomery, they have a need for STEM outreach. And so I built it more so to use it as a teaching tool to, it has the capabilities of doing pseudocode. So, when you're building something, when you're doing programming, it does take a different train of thought. And a lot of people don't understand that. So by taking that traffic light and saying, hey, you already know how this traffic light works, because, everybody's seen the traffic light, everybody knows how one works. So you don't have to explain the logistics behind the traffic light, but you do have to explain what is involved to actually make it change the colors that it's supposed to change.
Mm-hmm.
And so by using that as a teaching tool, people are able, especially the kids, they're like, "Ooh, it's a traffic light," and it's like, "Wait, is it real?" And because it's like 3.5 feet tall, so and it's
huge,
real.
It's huge.
And so, but people are always intrigued by it because of the fact of what it can do and the effort that it takes, and because of the fact it's so fascinating that something so small can run something of bigger size.
Exactly. All right. What else was I going to ask?
Okay. And so, for the record, the traffic light is actually programmed with Python. I have the code on my GitHub website, so if anybody's interested, the code is out there for it. I don't mind sharing it. It took me a while to figure out how to get it going because Python, when I went through school, Python was not a thing. So I learned the C++, I learned Java, and all of those languages.
Okay.
And now Python is a thing. And it's like, you got to learn Python. It's like, do I really need to know it? And so I use it in for that. But outside of that, I have no other use for it.
Okay, now let me ask you this, because we've been talking about the different types of coding languages.
Mm-hmm.
Once you learn one coding language,
Mm-hmm.
how difficult is it to learn another?
It's pretty much the example I give people is like talking British English and American English.
Okay.
It's like the pretty much sentence structures, the spellings.
Mm-hmm.
Some words are different. Subject-verb agreement is sometimes different. But for the most part, if you can do one, you can pretty much do the others. It's just how you write those are different. So, for instance, when it comes to Python, there's no semicolons. But in C#, C++, and Java, there's semicolons after each line. Spaces are critical in Python. In every other language that I'm aware of, they're not critical. So it's just really when it comes down to the syntax. But x equals 2 is x equals 2 in pretty much everything.
Okay. All right, I have another question.
Okay.
Can we, did you have more that you wanted to say about the different types of languages?
I mean, not really, but...
Okay, so let's explain the different types of jobs that are available for people who learn computer programming.
Okay, so there are a lot. There's no way I can list them all.
Print nice.
Yes, Terrell has his Python. See, but yes, there are infinite number of jobs. A lot of the jobs are, for the most part, are like building applications, maintaining applications, or even doing data analytics, networking. Because networkers, you don't think networking people actually have to do programs, but sometimes they go and write scripts that do monitoring for their, whatever networking process.
Okay.
So networking professionals is a lot of opportunity for it.
All right. And another question I have, because a lot of times people don't always go into computer programming because they don't understand what it is.
Right.
How did you get started?
So it was me tinkering back in high school, figuring out how to build web pages.
Ooh.
And so from there,
Hey, Jana.
went to college and, learned it in school. Got a job working at the IT office at UA when I was there. And so it just went from there.
Now, and Terrell is watching us, but Terrell and Kenny, you all are like super brilliant. Since I teach the kids and I do like super elementary stuff, y'all, they geniuses. So they have been teaching me a little bit of Python and Linux.
Linux, yeah.
So can you explain to them what Linux is?
So Linux is Linux pretty much runs a lot of things. So most people think that most computers have Windows, which is not true. Most computers actually have Linux. So for instance, AWS, majority of AWS, if not all of it, runs Linux-based applications. Majority of the websites in the world run Linux-based applications. And the reason most systems have Linux because they have a lower overhead in terms of what's required to make them do what they do.
Okay.
When it comes to high computing heavy intensive computing, Linux will do way better than Windows on any given day. And also, Linux is that skill that they should be teaching in school, in my opinion, but they don't. And so,
principals, teachers on here, y'all heard that,
right?
Y'all should be.
For instance, the Raspberry Pi. So the distribution of Raspberry Pi is Linux based. So there's a graphical interface for Raspberry Pi, but if you want to mostly, it's mostly Linux.
Okay, so I'm gonna interrupt you right there because like these are like, I'm not a coder per se, but y'all, let me tell y'all what we do with this Linux thing. So, and you guys should follow Kenny on Instagram. He is almost ENGR. And he hosts this class once a month. It was at Starbucks, but now he is doing live Linux lessons online. And you don't have to be a computer programmer to join. They are so nice to the rookies, and go on.
The goal is to get people to learn the skill, because at the end of the day, I have this gift. Why not share it? That's the benefit of, being able to reach out to other people and being able to share what I know. And so that other person they may already know some stuff, but by me sharing what I know, now they know more.
True.
And the benefit comes full circle too, because there's some conversations I have with other people that I've learned some stuff from them. It's like, I didn't know you could do that. It's like, yeah, just tweak it just like that. And it's like, oh, there you go.
Yeah, it's a whole community of computer programmers, y'all. But follow him, and he does these live lessons. So the last one he did, let's go back to the first one, because I just want to explain to them what we were doing and how you just kind of walked us through it.
Okay.
But I didn't understand, because I called you after the last one. I was like, but why am I doing it this way? Because I just did not understand. But they tell you how to go into the Linux system, the terminal, correct?
Right, terminal.
And you can basically make folders,
folders, files, and all of that.
And organize all of your things without going into an actual application.
Right.
Is that correct?
Mm-hmm.
All right.
And you can do the same thing on Windows. Most people are familiar with the graphical environment on Windows. When it comes to Linux, most people that use Linux are familiar with the command line because of just how it's structured.
All right. Now, let me ask you this question. If y'all have any questions, please, because I am so prepared over here, y'all. So please, okay? We need questions. But, I lost my train of thought. What was I going to ask? Let's talk about like an entry-level position. And I want you all to understand that I am a very mature woman. I'm not young. And I'm learning this new skill. And it's, y'all make it pretty easy for me to adjust and learn. What if I wanted to change careers?
So, if you want to change careers and be in programming?
In programming.
Okay. So,
okay, I don't want to change careers, but go on.
All right. So, changing careers is, it depends on where you're coming from and what you're going to.
Okay.
And the reason I say that because, like, an accountant, they're familiar with numbers, and a lot of accountants, from my experience, they have some knowledge of programming because they know how to build these elaborate spreadsheets, and spreadsheets do all kinds of computations and gets out this output. So for them, the gap will probably not be too far off. But if you're like an English teacher and you're trying to transition all the way over, it's probably going to be a bigger gap because of the fact the skills that you would need to know as a programmer, more like the logical thinking, being able to understand, assignments and structures of things. You don't necessarily have that in that particular profession.
Right.
And so transitioning would probably be a little bit more difficult because it requires you to think in a different way.
True. But I have found that, y'all, if you have not done this, get on like tinker.com or what else? Code.org. I started by just creating a student account for myself. And that's how I kind of figured out how I could teach my students. So when you all tell me some things, a lot of things, I understand because I've been doing the students version.
Okay.
You know, so it makes sense. Like if there's a loop or repeat or something like that.
Right.
Terrell was teaching me that. But in the visual block coding, they show up as repeat blocks, or it's just worded a little differently. Free Code Camp. Thank you, Terrell.com. But I think that everybody should. Do you agree?
There is if you really try, there is a use case for everybody to have some knowledge of programming. I've seen where, like, people that garden, they build out.
He gardens too, y'all.
I do. But I've seen where other people that garden, they build out, like, these Raspberry Pi devices. And the one guy, I can't recall what his YouTube channel is, but he got an Arduino for Christmas. And he was like, well, I don't know what to do with it. And so he figured out, hey, I like to grow vegetables. Or I think he was growing, like, basil and onions and stuff like that. You know, nothing too big. And so he was like, well, how about I use this to help me do that? And so he built it out, tinkering, using added sensors and all the other stuff. And he literally built the code from scratch that basically monitors the environment conditions for the vegetables.
Really?
And based upon that, he gets graphs. And based upon the graphs, he can say, okay, I need to go out here and water the vegetables.
Yeah,
so there's a use case for it in pretty much, I think, in every pretty much area of some sort.
Okay. Let me see what else. Help me out.
Okay. So some other things that I know we've talked a lot about coding, but if you're trying to transition, there are a number of other things that you'll probably want to learn as well from going from, I guess, one profession to another. So everybody's like, hey, I need to learn how to code, but there's other things like learning what version control is. So some people are familiar with it, some people are not. But it's kind of like when they, for instance, they print a book, and then they come out with a second edition, and then they come out with a third edition. That's pretty much how version control works when it comes to code. And so what you need to know with that is you use your version control system to track the changes that have been made. And let's say you're writing some code and you introduce a bug or a defect in that code. Well, you want to see where in there, because sometimes you'll write that code and it'll be a year or two before it actually shows up as a defect. So you need to be able to backtrack and say, all right, it introduced here. If I change this here, what after it may it break? And so that gives you that kind of that history in the sense of how to do that. So version control is important. The main player in version control is called Git. Git is the name of software that's used. The same guy that came up with Linux is the same guy that came up with Git. Linus Torvalds, I think is how you say his last name.
Okay.
So yeah, that guy's smart. But the number of sites like GitHub, there's a GitLab, and Azure, and I think Azure uses Git as well for its version control. So any of those, if you have any familiarity, GitHub and GitLab are both free. GitHub is very popular for holding code, but there are others as well. But that's the big one.
Okay.
Cloud computing is another thing. So AWS, you've probably heard of that if you shop with Amazon. They probably sent you an email or two saying, hey, got some AWS stuff over here. And also...
Terrell.
Huh?
Terrell.
Oh yeah, and Terrell. And also Microsoft Azure, I think that's how you say it. They're the two main players when it comes to cloud computing. You may not necessarily need to know how to do cloud computing, but you at least need to know the concepts and the pros and cons of doing it. Go ahead.
Can you explain what cloud computing is?
Yes. So cloud computing, the purpose of cloud computing is basically you're offloading your processes, applications, whatever the case may be, to infrastructure hosted by somebody else. What that means is the benefits in it is, so let's say you share a cloud server with 3 other people. Well, if those three other people do most of their computing during the daytime and you do yours during the nighttime, you're sharing that resource, and it allows you to, free up your maintaining of infrastructure. Instead, you're offloading it to somebody else. And so that has some also benefits because it's less hardware that you have to maintain.
Okay. I'm just trying to make it relate to like my iCloud.
Okay, so like your iCloud. So okay, iCloud is basically it is cloud computing. The iCloud serves as a backup resource. So like your phone would be the primary device. But if you throw your phone in the river, flush it down the sink, whatever the case,
then
you can go to the cloud and pull that same data back out.
You gotta explain it for us.
Right. And so but again, there's multiple use cases for it.
Okay.
Because like for instance, you can stream data from the cloud and never have that stuff on your device. Some corporate environments that have like real sensitive data, especially like for like the financial folks, they have a app that connects to the cloud, and it will show you the data on your phone, but the data's never downloaded to the phone. It's always staying in the cloud. For privacy, for encryption, for a number of reasons. A friend I know that works in the mortgage industry, they have physical computers, but their physical computers basically are a remote desktop to an actual computer that's sitting somewhere in a rack in a data center. So they can take that physical computer home, but it has no financial data on it. All of that is on that virtual device, which is sitting in the cloud. Yeah. So it has a number of use cases.
Okay. Let's see what else.
Okay. Databases. I would say databases. Which database? It varies. It's the storage part of the cloud. Yeah, storage part of the cloud. Databases are critical. There's a big debate now between relational and non-relational databases. Most of what I've dealt with in the past has been relational databases. And so relational databases, kind of think of like and this may be for you older people, you're going to laugh, but the Dewey Decimal System. It's kind of like a relational database. Okay. And so everything is organized in a standardized fashion with the numbering and so forth. Non-relational databases we're just gonna throw it out there, and it's kind of like you just randomly putting books on the shelf. But it knows where those books are when you go to query that data, but it's not structured in any particular format. So databases are a big thing because pretty much everything nowadays runs off of some sort of database. There has been a movement to try to get away from that, but I don't see that going away no time soon because it's too critical, especially in like banking and so forth, where you have to keep like a ledger, and so it's easy to keep that in a database versus putting it in just a text file or something like that nature, like some people are suggesting can be done.
Hey Mallory, got some questions? Let me see what else. Y'all don't have any questions? Come on, people. Helps. What else?
All right. So another thing, if you're trying to, going back to the point of breaking into the IT industry, build a portfolio. So those small projects that you think are like really insignificant, you can build those out and then put those onto your version control on GitHub. Okay. And so when you actually do build up,
Docker.
Yeah, I see. When you actually do build up to that level of, hey, I'm ready to go apply for a job in the new industry, you have your portfolio. And so when you get to that interview, when they ask you the questions of, well, what kind of experience you got? Well, go look online at my portfolio. Okay. And so you can reference that. And I always say, keep like all of your code that you build, even if it's crap. I stumbled upon code I wrote 10, 15 years ago way back in the files then somewhere. And so I'm now putting that on GitHub because it further validates that you actually do know how to write code. Okay. Docker. So Docker is a more newer concept. If you're familiar with virtual machines, it's similar to that, but not as intensive, if you will, when it comes to computing. Docker is basically you have a self-contained environment that can do whatever it needs to do. So you can create Docker. Think of like the metaphor that they use is containers on a ship. You know, you have the tractor trailer, takes it to the shipyard, and then it puts it on the ship. And so everything in that container does what it does. It's isolated from all the other stuff around it. And so the concept of Docker is similar to that of virtual machines in that this container can do whatever it is assigned to do, and everything else around it just revolves around it. It doesn't actually have to interact with it. The benefits of Docker, though, is that it uses less resources than a virtual machine because a lot of times when you get a virtual machine, you need a rather high-end computing device. So from my work experience, we had several virtual machines that were called hypervisors. And so these are racks, these are servers in a rack with 16 CPUs in them, processors. So that's a lot of computing power. And so, you know, but on that 16 processor device, you're running the equivalent of like 5 servers. So when it comes to processing and power consumption, it's less. Cause even though the hardware is like a $3,000 computer, but you're saving on the power consumption. And so Docker is even better now because, you know, it's similar concept, but it's less resource intensive. So you don't necessarily need a 16 core server. You could probably get away with like an 8 or 4 even and run Docker containers. Any more questions? Or any questions? It's fluctuating. And so one other benefit that you can do to try to get more familiar with code or coding in general is to go on sites like Freelance, Upwork, those type of sites where they have those outsourcing basically gigs, and search for coding homework assignments. Because some people actually outsource their...
Really?
Yeah. So like that business major that does not know how to code probably goes out there and will put the assignment out there, this is what I need. And basically somebody will do it for $5-10. And so what I suggest people, find those type of assignments, do them yourself. Okay. Now there's nobody that's going to check you, but you at least have the experience of these are the requirements and so forth. Because when you get a project that you need to do, they're going to give you a list of requirements and say, you know, it needs to do this, it needs to work with this database and so forth, and build it out. And that's pretty much all the homework assignments are set up the same way. It needs to do this set of items, build it out.
Okay. Sounds complicated, y'all. I promise you it's not as complicated.
It's not.
As it sounds. It's not. I think, is that it? How long have we been on here?
About 30 minutes.
Oh, you ready to wrap it up? Hey, y'all, listen. Hey, I think that's it. Does anybody have any questions before we wrap it up? Can you come back one day with your
the traffic light?
Traffic light?
Yeah.
Y'all need to see the traffic light.
I actually got to fix it because I did updates. So I did the operating system updates, and it doesn't work like it should work. It'll turn on, but it won't switch signals or nothing like that. So the goal is to rewrite the code for it now. So to try to make it a little bit easier.
And since you're not doing the kids now, like
yeah.
Oh, and Kenny is a part of NSB, and they provide.
So we do basically STEM activities. So building things and then discussing like how those things interact with the physics and so forth. A couple of activities that we've done this year has been like building catapults, and so from that you discuss the physics behind the catapult, why or I think we did. There's another thing called a lemon battery. So if you put I think it's a nail on one end and a penny on the other end, and then you connect it to a voltmeter or something like that, you can see the electrical charge that is in the battery. Okay. And so we do activities like that to get people engaged, get kids engaged in STEM, and understand the benefits of it. And all of us are in some sort of engineering field, so they're actually learning from actual engineers.
Yes, they are. And you guys provide this service for?
So it's grade school students, so from kindergarten to 12th grade. Then the students that participate, they'll have the opportunity to actually go to the actual NASB conference because they have competitions and stuff like
Oh,
that
I didn't know that.
at the conferences.
Okay.
So it's a big deal.
And you guys were providing the classes?
Yeah, so we do our sessions during the school year, obviously because of the circumstances that is canceled for the rest of this school year. But if things go back to a somewhat normal state, we'll start back up in September on the third Sunday of each month.
Okay. All right, guys. Thanks so much. Thank you, Kenny. I will try to provide you guys with some more STEM activities because I have a band back there with tons of stuff in it. And I'll try to do this a little more. Tech Talk Tuesdays. If you guys have anything you would like to discuss as it relates to technology, send me a message and I will try to get you some help or some information on that. If you would like to join me one day for Tech Talk Tuesday or for anything else, send me an inbox.
All right.
Thanks, y'all.
Yeah, have a good one.
All right.